Hello everyone. Class 12th, chapter number 6, lecture number 1. Chapter 6 is applications of derivative. Let us start with the first topic, derivative as a rate measurer. We'll consider let y equals f of x be a function of x. Let delta y represents change in y corresponding to delta x, which is a small change in x, right? So delta y upon delta x represents average rate of change of y with respect to x. Clear? Or we can say it represents the change in y due to a unit change in x, as x changes from x to x plus delta x. Now when this difference change in x, I say, it is very small, okay, that means it tends to 0. So I write this is what average rate of change, average rate of change. Okay, now if we write it as delta y by dx, where limit delta x tends to 0, it is a very small value, then this is converted to dy by dx, which is actually known as instantaneous rate of change of y with respect to x. Often we drop this word instantaneous, so in the complete chapter, throughout this chapter, the term dy by dx will represent rate of change, which is actually instantaneous rate of change. Clear? Let us apply this into the questions and see how derivative works in measuring the rate or the application of derivative. So let us start with exercise 6.1. Here comes question number 1. In question number 1, we have to find the rate of change of area of a circle with respect to its radius. That means we have to do differentiation with respect to radius of area, right? So dA upon dr represents rate of change of area with respect to radius. What is the formula of area of a circle? Pi r square. Taking pi as it is, d by dr of r square is 2r. Clear? Now this is dA by dr. We have to find dA by dr rate of change of area with the radius at r equals 3. So we will put here 3 in place of r. We get 6 pi. What will be the unit? Area square centimeter divided by radius centimeter. Clear? This is how you're going to solve question 1, first part. I think now second can be attempted similarly. Let us go to the next question. Here comes question number 3. The radius of the circle is increasing uniformly here, okay, at the rate of 3 centimeter per second. So we are given radius with respect to time because it is per second, 3 centimeter per second. Because it is increasing, we are taking a plus sign, right? If it would have been decreasing, I would have taken it minus 3. Find the rate at which the area, we have to find the rate at which area is increasing of the circle when the radius is 10 centimeter. Correct? Now, what is d by dt of A? D by dt of A means area, which is pi r square. That can be written as pi of r square, it will be 2r, and then of r it will be dr by dt. We have been given the value of radius, which is 10, and dr by dt, which is 6. So we get dr by dt is 3, not 6. So the answer that we get is 60 pi. Unit will be cubic square centimeter per second. Hence, the unit will be square centimeter per second. Clear? This is how you're going to solve question number 3. Let us go to the next question now. Here is question number 5. A stone is dropped into a quiet lake, okay, and waves move in circles at the speed of 5 centimeter per second. You know, when you drop a stone in a lake, there forms concentric circles. So what is actually changing there? The center is same in concentric circles and radius changes. So this 5 centimeter per second is the change of radius. Dr by dt equal to 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the area increasing? Again we have to calculate dA by dt. d by dt of area will be pi r square, which will be pi as it is into 2r into dr by dt. Now we have to calculate the rate of change of area at r equals 8 centimeter. Putting this 2 into 8, dr by dt is 5. Clear? So what is the answer we get? 80 pi. What will be the unit? Square centimeter, right, per second. So this is how you are going to solve by placing the value of r and dr by dt. Clear? Let us move to the next question. So the only thing in this question was to just see what is this, and which is rate of change of radius. Let us go to next. Question number 7. As you can see in the question number 7, they are saying the length x of a rectangle is decreasing. So if it is decreasing, and you know, so it is per minute, so dt will come d by dt of x. Decreasing, that means minus 5 centimeter per minute. And dy by dt, which is the width, it is given as increasing 4 centimeter per minute. This is the rate of increase of y. When x is 8 and y is 6, we have to find the rate of change of perimeter. So let us do the first part. Let p represents the perimeter. So we have to calculate dp by dt. d by dt of, the formula for perimeter is 2 into x plus y. 2 as it is. We will write dx by dt plus dy by dt. Putting the values, dx by dt is minus 5. dy by dt is 4. We get the answer as minus 2 centimeter per minute. So that means the rate of change of perimeter we have got, that means it is decreasing at the rate 2 centimeter per minute. Now let us solve for area. You know what is area equal to of a rectangle? It is length into breadth. So here it will be x into y. Differentiating both the sides with respect to t. X as it is dy by dt plus y as it is dx by dt. Putting the values of x, y and dy by dt and dx by dt. X is, you see, 8 here. dy by dt, you know, 4 centimeter per second. 4 plus y is 6 into dx by dt is minus 5 because it was decreasing. So 32 minus 30 we get, which is 2 centimeter square or square centimeter per second. So area is increasing at the rate 2 square centimeter per second. Let us now move to the next question. So here comes the next question. Question number 9. In question 9, a balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with radius. So to read this statement carefully is very important. Volume is increasing with radius, that means dv by dr we have to calculate this. When the letter is 10, that means the radius is 10 centimeter. So you know the formula for volume of the sphere. We will apply it. d by dr of volume of the sphere is 4 upon 3 pi r cube. So when we differentiate it, what we will get? Just see, 4 upon 3 into pi into 3r square. Correct. Let us put the value. 4 upon 3 into pi into 3 into r square will be 100. So what we get? 400 pi cubic centimeter per centimeter. Clear? So this will be the answer for question number 9. Let us go to the next question now. Here comes question number 11. In question 11, we have been given that a particle moves along the curve 6y equals x cube plus 2. Here we have to find the point on this curve. On this curve we have to find the point at which y coordinate, that means dy by dt, is changing 8 times as fast as x coordinate. So dy by dt will be equal to 8 times of dx by dt. Let us differentiate this equation. 6 dy by dt equals 3x square dx by dt. Differentiation of 2 with respect to t will be 0 because it is a constant number. Let us write in place of dy by dt 8 dx by dt. 6 into 8 dx by dt equals 3 into what is the value of x? Do we know that? We don't know. Let it be x square and dx by dt. Cancelling dx by dt on both the sides, we get the answer for x square as 48 upon 3, which is 16. Solving it, we get x as equal to plus minus 4. Now let us take another sheet. We are getting x as 4 and x as minus 4. Putting these values in the equation of curve because we want the points on curve. We will get 6y equals 4 cube plus 2, which is 64 plus 2, which comes out as 66. So y will be equal to 11. So 1 point we got 4, 11. When x is minus 4, we get minus 4 whole cube plus 2, which gives us minus 64 plus 2, which is minus 62. So y will be equal to minus 62 by 6, which is 2 3s are 2 1s are 2 3s are. So the another point is minus 4 comma minus 31 upon 3. So these are the 2 points on this curve at which the y coordinate change or the rate of change of y coordinate is 8 times as fast as the x coordinate. Clear? Let us go to another question. So the exercise is really simple if you understand it carefully. Here comes the next question, question number 16. Before this, one more question is there which I want to discuss. Let us first discuss that is question number 14. Okay, here is question number 14. In this, sand is pouring from a pipe at the rate of 12 cubic centimeter per second. Right, that means this is the volume. As cubic centimeter is given, rate of change of volume it is. The falling sand forms a cone on the ground. That means this is the rate of change of volume of cone. So we can write dV by dt is 12 cubic centimeter per second. Right. You know the formula for volume of a cone? 1 upon 3 pi r square h. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base, or we can write r is equal to 6h. Correct. Now let us put the value. d by dt of volume is 1 upon 3 pi r square h equals 12. Taking 1 upon 3 pi common, d by dt of instead of r we can write 6h whole square into h equals 12. So we will get here 1 upon 3 pi into d by dt of 36h cube equals 12. Solving it further, we will get 1 upon 3 pi into 36 into h cube will be 3h square equals 12. Also we have done for h cube, then we do for h, we get dh by dt along with it. Putting the value, we can cancel it like this. 12 and 12 will get cancelled. So we have pi into 3 into h square is, just see, value of h is given to us. It is 4 centimeter in the question, which will be 16 dh by dt equals 1. So from here dh by dt will be 1 upon 48 pi. Unit will be centimeter per second. Clear? This is how we are going to solve question number 14. Now let us discuss question 16. Here in question number 16, the total revenue in rupees received from the sale of X units of a product is given by, this is the revenue function in terms of X. We have to find the marginal value when X is equal to 7. So we are going to differentiate it. D by dx of R of X d by dx of r of x means 13x square plus 26x plus 15. Differentiating it, we get 26x plus 26. If we take 26 common, we are having x plus 1. We have to calculate at x equals 7. So putting x as 7, 26 into 8 we will get, which is rupees 208. Clear? So this is the marginal revenue that we have. Clear? One more question. Let us discuss that. Let us discuss this last question for today. It is question number 10 of exercise 6.1. A ladder is there which is 5 meter long, is leaning against a wall. Let us draw a rough diagram. So let us suppose this is the wall. Okay. And this is the ladder which is 5 meter long. So 5 meter long, which is 500 centimeter. Let us name it as ABC. Okay. Now what are they saying? The bottom of the ladder, that means this one, okay, is pulled along the ground away from the wall. So this side you are pulling it. So when you pull it, you see the ladder will become like this. So height of the ladder on the wall will decrease. So let us consider this complete AB as Y, this as X, BC as X. Okay, or we can just write it as Y, this as X. Now they are saying how fast. Okay, at the rate of 2 centimeter per second we are pulling it. So if we are considering this as X, so what is actually changing? The distance between both the foot of the wall and the ladder. So it is dx by dt. It is 2 centimeter per second. How fast is the height decreasing? So we have to calculate dy by dt. When the ladder is 4 meter away, that means x is equal to 4 meter. Clear? This we have to calculate. Now when we solve it, just to say according to Pythagoras theorem, we can write x square plus y square equals 5 square, or I say 500 square. So we can get it as whatever is there, 500 square. Let us differentiate it. We get 2x dx by dt plus 2y dy by dt, and differentiation of this will be 0. Now from this only, we don't know the value of here it will be 2y. So we don't know the value of y. We know the value of x is 4. We know the value of this, right, which is 5. So from the expression which is x square plus y square equals 500. Let us just calculate it in meters and we'll convert into centimeters. So x is 4 meter. So 4 meter square plus y square equals 25 square meter. So from here y will be 25 minus 16, which is 9. So when you take the square root, you get just 3. So y is equal to 3 meter. That means 300 centimeter. Put it here. 2 into x is how much? 400 centimeters. Dx by dt is 2 plus 2 into y we just calculate is 300 centimeters. It is already in meters, into dy by dt equals 0. Okay. Now we will be solving it. We get dy by dt as equal to minus 1600 upon 600. That gives answer as minus 8 upon 3 centimeter per second. So this will be the answer, or the rate at which the height on the wall of the ladder decreases when the foot is 4 meter away from the wall. Clear? So now in homework, exercise 6.1 only you will be doing. So just writing the homework questions for you. You will do question 1, second part, question number 2, question number 4, 6, 8, 12, 13, 15 and 17. So do go through the classwork questions carefully, also the concept, and do these questions. These will be definitely done. The exercise is really easy, and come up with the doubts tomorrow. Okay, so subscribe our channel at Quark for more upcoming videos and like the videos. Thank you.